So today you're going to learn how to factor something that is called a difference of squares. So you need to recall what a square term is. What is a perfect square? So if I draw a square, what do you know about a square? Length and width are the same. So if I say the length is 4, the width is 4. What is the area of that square? 4 times 4 equals 16. 16 is a perfect square because the length and the width are a whole number. Okay, the length and width are 4. I can also write it as 4 squared. Now if I tell you the area of a square, a perfect square is, let's say, 25. What are the dimensions of the square? 5. So we know that the square root of 25 is equal to 5. So let's find the positive square root of each. Like I said, this is easy. This is a review. What is the square root of 9?
3.
Good. So let's copy that down. I'll write it like, let me actually write square root of 9 equals 3. What is the square root of 25? I just did that example. 5. Good. Now we have a variable. What is the square root of x squared? Good. Okay, if I draw a square, and we don't know the length and width, and I label it as x times x can be written as x squared, right? So the root would be x. The square root of x squared is always going to be x. Now look at D. D is a little bit different. 4x squared. So we look at the numerical part. What is the square root of 4? What is the square root of x squared? X. So the square root of 4x squared would be 2x. Okay, does that make sense? We had 2 more to finish. Example 2, what is the square root of 16? 4. And what is the square root of 9? We just did that. How can I write this as a power? 4 to the power of 2 equals 16, and 3 to the power of 2 is equal to 9. Okay, that was for example 2. They want you to write it as a power. 4 to the power of 2 equals 16. 4 times 4 is equal to 16. You need to be able to recognize what a difference of squares means. Well, we've talked about squares. How do you know if a number is a perfect square? Okay, we have a list on the other page of perfect squares. If it's a number that you can find the square root of and it's not a decimal, it's a square. What do you think this means? We're trying to recognize if these expressions are difference of squares. What does difference mean in math?
Subtraction.
Right. So if they are, copy this down please, separated by subtraction.
Wait, what?
If the 2 terms are separated by a subtraction sign, then that's part of our checklist, okay? Then we know that it's possibly a difference of squares. So we have to check to see, is it separated by subtraction, and is each term a perfect square? So we're going to go through this little checklist for each one, okay? Yep.
So if the 2 terms are separated
By subtraction. So we're going to, question A, is this a difference of squares? Yes or no? Let's go through our checklist. Is it separated by subtraction? Correct. Yes, it is. Are both terms, is each term a perfect square? Let's look at the first term. Is x squared a perfect square? Is 25 a perfect square? Yes. Okay, so the answer to this is yes. That is a difference of squares. Let's look at B. X squared plus 16. Is this a difference of squares? Is it separated by subtraction? No. So automatically, I know the answer has to be no. Shh. Is each term a perfect square?
Yes.
It is, but it's not separated by subtraction, so it cannot be called a difference of squares. I cannot factor this using a difference of squares method, okay, because it's not separated by subtraction. So the answer is no. What about C? 1 minus 49x squared. Checklist, number 1. Is it separated by subtraction? Is each term a difference of squares? Is 1 a perfect square? What's the square root of 1? 1 times 1. So yes, that is, oh, it wasn't. Okay, it's separated by addition, so it cannot be a difference of squares.
What do we do now?
Okay, so just as a review, I want you to square all of these numbers so that you will be able to recognize what a perfect square is. 1 squared is, what's 1 times 1? What's 2 times 2? 3 times 3? Okay, all of these numbers that I'm writing are all going to be perfect squares. These are all called perfect squares because the square root of them is a whole number, okay? You need to recognize, for this section, you need to know what a perfect square is. 4 times 4, and so on, you guys. Okay, so here's just a short list of perfect squares. Like I said, you need to be able to recognize a number and see if it is a perfect square. So if I write down the number 10,
Perfect.
was 10 on our list? 1, 4, 9, 16. No, it was not on our list. 10 is not a perfect square. Okay, you need to recognize what a perfect square is. The square root of 10 is a decimal. What is it? What is the square root of 10? Is 10 a perfect square? Is 10 a perfect square? Are the length and width of an area that equals 10 the same? What is the square root of 10? Are there two numbers you can multiply together that are the same that will equal 10? No. What are some, we did this yesterday, what are some factors of 10? 5 and 2. That is not a perfect square. So 10 is not a perfect square. Was it on our list? The square root of 10 is approximately equal to 3.16. That's a decimal. This is not going to be a perfect square. So, what does it mean to factor? You're writing it as a product, right? You're breaking it apart. You're figuring out what two things can I multiply together to give me back the answer. That's what you just did on your quiz, right? You're looking for two things you multiply together. Now, yesterday you factored using greatest common factor. And like I said, looking at x squared and 25, is there a greatest common factor? Do these two terms have a greatest common factor? No. I can't figure out something that I can divide into x squared and 25 that's the same, right? Okay? So once you recognize, what we just did was we have to recognize if it is a difference of squares. And these were the two examples that were difference of squares. How do you know that again?
Because square root's all number.
Because they're both perfect squares. They're both squares, and they're separated by subtraction. Once you recognize if it's a perfect square, this is how we factor it. We're looking for two things that multiply together to give us x squared. So what's the square root of x squared? What times what gives us x squared? Okay, and the second term, what's the square root of 25? So I know that x times x will give me back to x squared, and 5 times 5 gives me 25, right? Right? We're looking for two things that multiply together to give us the answer. The terms are separated by subtraction. So we did this yesterday. What times what will give you a negative? A negative and a negative, does that give you a negative? A positive and a positive give you a negative? What gives you a negative? Positive times a positive times a negative. And that's it. This is factored form. X plus 5 times x minus 5. That's factored. That's like what you did yesterday, but this is much easier, right? So you're looking for two things that multiply together to give you back the answer. Is it separated by subtraction? Is this a perfect square? Is this a perfect square? What is the square root of 1? Okay, so that has to be my first term, because it's my first term. I'm finding the square root of the first term. What is the square root of 49? X squared. Square root of 49 is square root of x squared. And it has to be, what two signs give you a negative? A positive and a negative. A positive times a negative gives you a negative. I can also write it as negative and positive also gives you a negative. So it doesn't matter what order you write it in, as long as one is negative and one is positive, and that's it. That's factored form. 1 minus 7x, bracket 1 plus 7x. That is the answer. That's it. Okay, we know it's a difference of squares because it's separated by subtraction. This is a perfect square, and this is a perfect square. So what is the square root of 16x squared? 4 what? Good. What is the square root of 121? What are the signs I have to put? Positive and a negative. That's it. You factored it.